Hi, welcome guys. Welcome to my YouTube channel. Today we are going to design a stack with increment operation. This is basically a simple problem which we have in front of us, which is saying that we have to create a class where a user can perform three operations, which is push, pop, and increment. So increment is little tricky, but we'll get to it. First, we have to write a constructor for it. So let me say init is a for those who are new for Python. Init is a function is same as a constructor in Java. If you are done Java in your like you have learned Java previously, you can know that there is a constructor for every class. That is, the constructor is something that automatically runs when object is created of that class. So here this init, we are overriding it, the constructor. Now we are going to give two values, which is I'm going to create a self.stack, which will be my list for this problem, and they are also given the max size till where I can put elements in my stack. So I'll declare a self.max size also, so that I can keep track of elements which are being inserted in my list. So that is my init class. So we have created a list and the max size for that. Like this many elements I can insert into the stack. So the first function the user can perform is push function. So after initializing our object of a class, now user can perform three operations, which is push, pop, and increment. So the first one is push. So there is a condition. If the elements in the stack is approximately full of size, like a stack is full. What is stack is full? Like if stack size is 10, say they have given max size as 10, there we can only push elements till 10 size. Okay, so we are going to check first whether our elements in the stack is less than 10 or it's more than 10. If it's less than 10, we're going to push the element which are given. If we have our stack is overflowed or stack is does not have size at all, we are not going to do anything because we don't have to return anything here. If they have asked like we have to say if we have pushed or not, then we will write the else condition. Otherwise we'll just write the pushing condition. I'll take if length of self dot stack is less than max size, then I'm going to push this element. So for that, self dot stack dot append, what we're going to append, this is the value which we're going to append here. So else condition we are not going to write because they are not going to ask whether we have pushed or not. So in push, third this one function given in this class, and the second function that user can perform is pop function. So here a user will pop the last element if it exists, or else we have to go return -1. So for that we have to check if the stack is consisting of elements or not. How? Now we have to check the stack size. If it's more than 0, then we assume that stack has elements. Otherwise we'll return -1. For that I'll write a condition of if length of, like before in what I've written for push stack, here I'll check if it's more than 0. If it's more than 0, we'll take a variable which will hold the popped value of stack dot pop is a function, so we'll put a bracket here. Now we'll just return the value. If the stack is empty, what we'll do, if the stack is empty, we'll return just -1. Yeah. Now one more function is there. I hopefully think that pop function is correct. So one more function is there, which is increment. This is a little bit tricky because here they are telling if the k number of elements exist in our stack, we are going to increase those only k elements. But if the elements are less than k, we are going to increase all the elements by value they have given. So for that, there is like the effective way of doing it. So I'll take a size variable which holds minimum value of k and length of self.stack. So here what I'm doing is I'll take the minimum value of between k and our length of stack. So what I'm doing here, if the k is less than our elements which we have in our stack, then we'll take k as our size. So it will be more easier. If I have to check for individual thing, it will be more, and it will be consumption of time will be more and space will be more. So this is the most effective way which I can think of right now. So size, I'll take I'll put a for condition here for I in range function we are going to use for the size. So we are going to increase the size, whatever the value it consists, we are going to increase each element till size. For that, self dot stack of I will increase by value. So here also we are not going to return anything because they are not going to ask for any value we have incremented or anything. So hopefully this works. Okay, max size, it should be self. Yeah. Yep, there you go. So you can do it better also. Even you can take another list here. So this was just a basic method which I've taught you just to understand how the class works, how the constructor works, and each function takes self as an argument here.